When you hear about astronomy in the media, you nearly always hear about pictures. With good reason, astronomy is full of absolutely gorgeous pretty pictures. But in fact, the vast majority of what professional astronomers such as ourselves do is not take pictures, but take spectra. It's somewhere between 70 and 90% of all observations made in astronomy. So what is a spectrum, and why do we bother when the pictures are so nice? Well, the basic idea is you take your light from whatever you're looking at, star, galaxy, nebula. Your telescope collects it and feeds it into a spectrograph. The light coming into the spectrograph is made up of many different wavelengths. In the spectrograph, you have some sort of device which spreads it out. Typically it's something called a diffraction grating, but a prism would do as well. And it will send long wavelength light, like red light one way, and short wavelength light, like blue light the other way, and for that matter ultraviolet down here, and infrared up there. And then you have a detector, and you measure how much light falls on each pixel here. You read that out, send it to a computer monitor, and you'll get a spectrum, which is typically a graph showing the wavelength on the x-axis and the energy per unit wavelength on the y-axis. What do these spectra look like? Well, normally, if you're looking at something like a star or a galaxy, you'll have spectrum that goes up and goes down, and where it peaks, that's telling you that it sends most of its energy out at these sort of wavelengths, which in this case might be sort of green in the middle of the optical spectrum. If it peaks down here, it's telling you it's a very hot star. If it's peaking down there, it's telling you a very cold star or galaxy. But usually superimposed on this are dips called absorption lines. And these always occur at particular wavelengths. And what you do when you see a spectrum like this is you look at what wavelength. For example, if you're seeing an absorption line at a wavelength of 656.3 nanometers, you would then compare it to a list of wavelengths as measured from gases in the lab, and you'd find, for example, that this corresponds to hydrogen. And you can look up other lines. Once again, compare them to the list of wavelengths in the lab and work out what elements are present in the star or galaxy or whatever it is you're looking at. There's a lot more to spectra, but that's all you need to know for the moment.